Okay, friends, here we go with our bell ringer assignment. Remember, this is just, let's see, 5 problems for you to do each day. There's one slide per day. And I'm going to keep making these videos until we kind of get into the routine because a lot of the concepts will repeat. So after a couple days, you probably won't need a daily video, but for now, we can go ahead and do a daily video until it becomes routine. Okay, so let's get, guys. All right, now remember, when you're watching these videos, keep a pencil and a piece of paper handy. Do the problems as I'm doing them. Pause the video, solve it yourself, and then double check using the answer that I show you in the video, okay? Hope you're having an awesome day. Let me know if I can help you with anything. Started, you guys stay with me. Remember that anytime you see a problem where the standard lists it as MD, that's a measurement problem. MD stands for measurement and data. And here they're asking us to figure out how many ounces are in 10 pounds. And then they kind of give us a hint because they say, hey, remember 1 pound, LB stands for pound. That's a question I always get. What does LB stand for? That's pound. And OZ, that stands for ounces. Okay, so think of ounces as being like what a baby weighs when it's first born. They'll say like, oh, your sweet little baby boy weighs 6 pounds, 3 ounces. So an ounce is a smaller unit of measurement than a pound. A pound you could think of, what are some things that come in pounds? Like you could buy a pound bag of sugar. Let's draw that so we can kind of visualize it. So let's say this is 1 pound of sugar, and that would equal 16 ounces of sugar. All right, so if we're trying to figure out how many ounces are in 10 pounds, and we know that 1 pound is 16 ounces, let's kind of just keep going with this pattern and see if we can puzzle it out together. 2 pounds would be 32 ounces. 3 pounds, let's see, what would that be? Would that be 48? 32 plus 10 is 32. Plus 6 more, yeah, that's 48. What would 4 pounds be? 48 plus 10 would get us to 58. And then 58 plus 6 more would be 64, wouldn't it? What about 5 pounds? You know what? I think an easier way would be to take our number of pounds, multiply it by our ounces in each pound to get our total. So for this, we could do 5 times 10, which would get us 50. And then 5 times 6 would get us 30, so that would be 80. And then for our 10 pounds, let's do 10 pounds times 16 ounces in each pound. That's going to give us 160 ounces. And that makes sense because 5 pounds is half of 10, and 80 ounces is half of 160 ounces. So that makes sense. Okay, I'm gonna put 160 ounces here. Now let's do 48 ounces. Ooh, this one's a little trickier. 48 ounces equals how many pounds? Now I kind of already figured that out just because of the way I was solving it. So I've already written that that's 3 pounds, but also if I didn't know that, I would have to do 48 ounces divided by, because it's got to be the opposite strategy of what I did before. 48 ounces divided by 16 ounces in each pound would get me 3 pounds. Okay, that's that one. Now remember, as you're watching these videos, it's really important to keep a piece of paper and a pencil handy. Pause my video. Every time I'm doing a step on the video, you should be solving it on your own. So you're gonna pause, solve, check. Pause, solve, check. You should not be just sitting and passively watching this video. First of all, that's going to be extremely boring. And also, you won't really learn all that much math if you just watch me solve it. So if you do not have a piece of paper and a pencil, I need you to pause me and go get one, please. All right, here is our daily fact family. Yay! We're going to do our fact family for 4, 6, and 24. So let's see, 4 times 6, that gives me 24. And then thanks to the commutative property of multiplication, I know that I can multiply these in either order and they mean the same thing. They give me the same product. Remember, with multiplication, we're multiplying factor times factor to get a product. All right, now for this one, 24 divided by 6 will get me 4, and 24 divided by 4 will get me 6. All right. Let's see. Ooh, line plot. Goody, goody, goody. I love these. These are so fun. All right, so remember, MD stands for measurement and data. Here's our line plot. And your line plot is a way to represent data. Now, normally, let's say this was like number of pages someone read each night, or number of pages a class read each night, or something like that. You would label your x-axis, which is this horizontal axis going side to side here. You would label your axis, but in this case, we don't know what this data represents, so we really can't give our axis a label. We need to look and find the smallest value, which is 15. So I'm going to have 15 here. And then our largest value, which goes all the way up to 85. Okay, now your line plot can have larger values than that. Like I could go up to 90 if I wanted to. I just won't have any x's above my 90. Or I could go down to 10. I just won't have an x above my 10. And I also have to think about how I want to spread out these numbers. 10, 15, let's see if I can do it by 5s. 20, 25, 30 is going to be a little trickier. 35. See, I can't really fit between 35 and 85. I really don't have enough space to do that. So I don't think that's going to work. Sometimes with math, you're going to have to try a couple of different things before you find exactly what works for you. I wonder if I could rotate my line plot the other way and give myself more space. Let me pause for just 1 second. All right, so let's say I want to spread out my values between 0 and 100 with 50, 10, 20, 30, 40, 50, 60, 70, 80, 90. Yeah, I think that will work. Okay, so let's label. 15 is going to be right in the middle between 10 and 20, of course. So I've got my 15. 85 is going to be over here in between my 80 and my 90. So I'll put an X there. 25 will be in between my 20 and my 30.
Can you bring it to me and let me look at it? Mm-hmm. 25, almost done, and 30. Point out that it's really important, first of all, carefully cross out each value as you put it on your line plot, and that way you know that you're not adding a value more than once. And also, let's just think about what these x's represent. Each one of these x's represents one value showing up on our line plot. So let's just imagine that this is like the number of pages kids in a class read. This would be like one kid read 15 pages last night. So in this case, we actually have 2 kids who read 15 pages last night. And here we have just one kid who read 20 pages last night, and so on. So now we're going to do this question about volume. Sorry, I don't know. Remember, this is showing you have one red layer. A blue layer in the middle. So one thing about these problems is just getting used to how it is showing you the three-dimensional shape and knowing which part.
Okay, so now we can see our 3 layers, and let's look at the top green layer and think about how many cubes are represented in that green layer. So let me label the dimensions here. Let's see, we've got 1, 2, 3, 4, 5 times 1, 2, 3, 4, 5. Okay, so 5 times 5, that gives this top layer here has an area of 25 cubes, and there are 3 layers. So 25 times 3, how many cents do you have if you have 3 quarters? 75. So 75 cubic units, that's our volume for this one. All right, here we have a beautiful shape, and we're going to name and tell everything we can about this shape. Now remember, we talked about parallel lines. Parallel lines are the lines that travel along side by side like railroad tracks. And they never, ever, ever move towards each other. Like these lines are not parallel because the distance here is smaller than the distance here. So those are not parallel. These parallel lines, or these lines, are parallel because they are always going to be the same distance apart, no matter how far we could extend those lines into infinity and beyond, and they would always be the same distance apart. So we have one set of parallel sides, one set of parallel sides, and we have some angles here. Let's look at our angles. Do you think this is an obtuse angle or an acute angle that I'm shading in red here? Those angles are acute. They are smaller than 90 degrees. Okay, and here we have these blue angles. What are these? Acute or obtuse? Are they bigger than 90 degrees or are they smaller? So if I draw a line going this way, that's my 90-degree angle, and then this is extra, so that shows me that it's bigger than 90 degrees. Same thing here. I've got 90 degrees, and then this is extra. So there are 2 obtuse angles. Now it is a quadrilateral because it has 4 sides. Okay. And I guess that's it. Did I do all 6 problems? Wow.